Hello ladies, in this video we're going to go through the difficult questions for 5E, which is looking at the total surface area of three-dimensional shapes. So usually we call a three-dimensional shape a prism, but you can also have pyramids, you might call them a cube, a sphere, although I don't think we're looking at spheres in this section, etc. So let's get started. When you do the total surface area, it's always a good idea to think about how many sides of your shape you have. So we've got a few examples here in question 4. I'm not going to do every single one of them. I'll start with A. Just looking now, question D looks like a bit of a pain because you're looking at a triangular pyramid from, I suppose, a bird's eye view, maybe. It depends how you look at it. Okay, so we'll do a few different ones and then maybe E. All right, so question A. Now it's going to be hard because I'll need to keep scrolling. Let me just get my pink. Okay, so question A. I'm not going to redraw it. We have this front side here. We have the back. So that's 2 sides so far. We have the bottom, which is 3, and then we've got the 2 triangular ends. So we've got 5 sides altogether. So when you're doing your total surface area, just think you've got to add 5 sides together. And you might not write them individually like this because some of the sides are going to be the same. So you might do 2 times something, but it's a good idea to know how many sides you have or how many surfaces you have. The other thing you should do is actually redraw each surface. So I know I've got 2 triangles. So my ends are both triangles and they're actually the same. That's a right, indicates a right angle on the triangle. And the side lengths are 3, 4, 3, 5. So let me just write that up. So 4, 3, and 5. Okay, so you can see the 4, the 3, and then the 5 down the other end. But it doesn't really matter because we're going to do the area of the triangle and we don't need that length 5. All right, we've got this top part and the side part and the bottom. Now they're all rectangles. So the next thing you should say is ask yourself is, are they all the same? Now I know with this triangle, each side isn't the same. Therefore, your rectangles are going to be different. So we've got, even though we've got 2 of these triangles, so times 2, we're going to have 3 different types of rectangles. So I'm going to just draw them now. Now, you don't have to draw them to scale. Just know that you've got 3 different rectangles. So one is the front, one is the back, and one is like the base of the rectangle. Now, they all have the same length, which is 8, but they all differ on the width. So this front rectangle has a width of 5, the back one is 4, and then the base is 3. So I'm just going to redo that now. So one is 3, one is 4, and one is 5. And I think from memory the length was 8. I might just need to double check that. Okay. So now we have our 5 shapes. We've got the 2 triangles and the 3 rectangles. So let's plug everything in. So our triangle formula, we've got 2 of them. So I'm going to write 2. And the formula is a half base times height. And then you got your your rectangle, sorry. So we're going to have length times width for that rectangle. And you might want to call that rectangle 1. So rectangle 1. Then we've got length times width for rectangle 2. And then we've got length times width for rectangle 3. Okay, so just showing that they're all different. I don't know why that notification always comes up. All right, so let's plug things in. So our triangle, the base is 3 and the height is 4. Now you may have skip this step, that's fine. Just showing you the formulas. Your first triangle is going to be 8 times 3. The second triangle is 8 times 4. And the last triangle is 8 times 5. And then we just add everything together. All right, so a half times 4 times 3. So 4 times 3 is 12. And then multiply that by a half is going to be 6. So we've got 2 times 6 is 12. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. And we just need to add them all up. So 40 and 32 is 72. 92, 96, 98, 108. So we have 108 centimeters, and because we're working with surface area, centimeters squared. Okay. All right, let's look at another question. So I'm going to clear that so we've got a bit of working space. All right, so everything has been removed. I said I was going to do D, so I might do D now. Okay. Oh gosh, that's a terrible D. But anyway. All right, so here I have 4 sides, so my total surface area. Okay, so when you think about it, you've got the 3 triangular sides and the triangular bottom. So it's going to be 4 sides, 4 surfaces. And each surface is a triangle. So first of all, you've got to say, are they the same? Now, having a look at these 2 little lines means that these sides are the same. So one triangle, okay, is going to have sides of 4, 4, and 4. Now, this is very, very hard to kind of see. Now, the other 2 triangles, I'm going to just redraw just to make sure. So is that a height of 3.5? It looks like it says a height of 3.5. Okay, and then your base height is 6.2. Oh, it's a terrible triangle. So 6.2. And no, that's the height, sorry. Let me just delete that. It's hard when you don't have the diagram right in front of you. So the height so you can see that arrow. This diagram is terrible, but we'll do the question anyway. So there's the 6.2, the height of that. And I can see that length there is going to be, or it is 4. So that has a base of 4. And let's just look carefully at each other side. Now, we're going to assume that this second triangle here is the base by the looks of it, and every other side is the same. I don't know. All right, so I've just looked at the diagram in quite a bit of detail. This bottom triangle, which is the first one I drew, looks like that is your base, and then the other 3 triangles are all like this, and that kind of makes sense because your 3 triangles, the base of each triangle would stand on the side of the base 4. So we're going to have 3 of this type of triangle. So remember, we need 4 different surfaces. So one of those surfaces is this base triangle, and the 3 sides are made up of this triangle. All right, so let's put in our formulas. So we're going to have area of a triangle is a half base times height. Now remember, we have 2 triangles here, so I'm going to label them triangle 1 plus a half base times height for triangle 2. And then let's just substitute that in. So the first triangle, the base is 4. Whoops, and what I didn't do, we've got 3 lots of this. Okay, so 3 lots of triangle 2. So a half times base, which is 4, times height, 3.5. And then 3 times this triangle, so half times 4 times 6.2. And you can just then plug it into your calculator. So I'm going to go ahead and do that. All right, and you should get, whoops, where have we got? 44.2, and I think we're dealing with centimeters. Let's just double check. Centimeters squared. All right, so I'm not going to do every single one of these, but I might just look at E because E is slightly different. And again, I'm going to delete what I've just got there. All right, so for E, first of all, think about how many surfaces you have. So we've got the front and the back. So your total surface area, we've got the front, the back, okay, and it's like an L shape. Then we've got like a step. So we've got 1, 2, 3, 4. Now, it doesn't matter if you don't leave enough space, it's fine. And then we've got kind of like the back here and then the base. So we've got another 2 going on. So in total, let's just count them and make sure that we've done it correctly. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's draw our individual shapes. So we have kind of like the L shape. And we've got 2 of them. We've got the front one and the back one. So we've got 2 of them. And let's write down the dimensions. So this is 2. And these sides are all 1. Okay, we might talk about how to find the area of that in a second. Then we've got like the stairs, the rectangle on the stairs. And each of them is actually the same because we're going up 1, across 1, up 1, across 1. So we've actually got 4 that are the same and their measurements are 2 by 1. Sorry, poor multiplication sign. And then we have the back and the bottom, and that is actually a rectangle. So if you can kind of picture that, because this is kind of like a cube that has had this section cut out of it. So we've got at the back a square and the base is also a square. So we've got the back and the base are actually the same. So we've got 2 of them. All right, so just make sure you've got all your surfaces accounted for. So we've got 2, 6, and 8. Awesome, because remember we identified 8 different surfaces. So let's go ahead and substitute everything in, or maybe write down our formulas first. All right, so we're going to start with this composite shape up the top. So as you can see, I've got a black line there because I had to edit this video and I've just put it back and I forgot to delete the black line. But anyway, with your composite shape here, this L shape, let's separate it into a square and a rectangle. So if we look at the square first, the area of that is 1 times 1, which is 1. And the area of this rectangle is 2 times 1, which is 2. So we have 2 lots of that. So it's going to be 2 times, we're going to add the area together. So the total area of this shape is 3. So we've got 2 lots of 3. Here we've got a rectangle. So 2 times 1 is 2. So 2 lots of 4. Or 4 lots of 2. I might do same thing. And 2 times 2 is 4. And we've got 2 of them. So it's going to be 2 times 4. And then we just add everything together. So 6 plus 8 plus 8 gives you, what's that, 1622 centimeters squared. All right, moving on to question 6. All right, so I added this question in because it's a problem and there's no diagram. So diagrams, questions are always hard if you're not given a diagram. So here we've got a rectangular box. Doesn't matter what else is happening. Let's deal with this rectangular box first. Now, if you're not an artist, and I know I always joke about I'm really good at drawing diagrams, just draw your rectangle first. And then if you can draw a rectangle of a similar size, but just draw it a little bit to the side, like that. And then connect your opposing corners. Okay, and there's your box. Okay, you can see through. It's not ideal because you obviously when you look at a box you can't see those sides unless it was a clear box, but you get the gist. How much is required to cover the entire box if the dimensions are 1.3, 1.5 and 1.9? Now it doesn't matter for rectangular prisms where you actually put these values, so I'm just going to put them there, but you can have them in any order. Now we're looking at the total surface area. Now, like I did before, I counted up how many surfaces we have. A rectangular prism will always have 6 surfaces, okay, so 4 around the side and 2 at the end. So you can, if you like, continue to do that. So we're at 1, 2, 3, 4, 5, 6, and then draw the different shapes. So we've got the front of the box. Now, because it's a rectangular prism, each rectangle is going to be multiplied by 2. So if you think this side of the box is going to be the same as this side, so 1.5, 1.3. All right, and then just draw your other 2 sides. So we've got 2 of, depending on what side you're looking at. So just choose another 2 numbers, not randomly, obviously. And then we haven't done 1.3 times 1.9, so I'm going to do that one. We've got 2 of them. All right, so with our calculation, I'm not going to write in all the formulas because the area of a rectangle is length times width. Now you can do that here, so 1.5 times 1.3, but just remember you will have to know how to show your working out. So if you wanted to, I would say, all right, 2 times 1.5 times 1.3. Okay, so that one's the first rectangle's accounted for, plus 2 times 1.5 times 1.9, and I'm going to write over my diagram, so let me just get rid of it. Such a good diagram too. And then we've got the last 2, 1.3 times 1.9. And I'm not going to sit here and do multiplication by multiplying decimals, so I'm just going to have a look at the answer. All right, and assuming that the textbook is correct, you should get 14.54, and we're working with meters squared. All right, let's move on to question 8. Now, I don't think I'm going to do these questions because I'm looking at the time on the video and it's getting quite long. So I'm going to start you off and see if you can keep going. So question 8, the outside 4 walls and roof of a barn shown are to be painted. Find the surface area of the barn, not including the floor. Okay, so when we're thinking about our total surface area, we don't include the floor. And if 1 litre of paint covers 10 metres squared, find out how many litres are required to complete the job. All right, so let's look at question A first. So we're doing the total surface area. Now, again, write out how many surfaces you have. Now, the front of the barn is a rectangle. Just making sure it wasn't a square. A rectangle and a triangle. I would actually treat them separately. So we're going to have our triangles. Okay, so we've got 2 of them. So we've got 1 triangle plus another triangle. Then we've got the 2 rectangles at either end. Just going to write the base of that triangle is 2.4 and its height, this is tricky. The height of the whole barn is 3.5, so that means the height of this is going to be 1.5. All right, so let's do now the rectangle part that the triangle is sitting on. So it's 2.4 and 2, and we've got 2 of them. So we've got those 2 surfaces. And then we've got the sides here of the barn. So I'm just going to scroll up there, rectangles 2. So we've got 2 of them. And what are they? 4 by 2. And then we've got the slant of the roof, okay, and which is also a rectangle. So we've got 2 of them. Okay, so that's going to be 1.9 times 4. Okay, so I've done all that as we were counting. So let's just go and make sure we've got them all accounted for. Remember, we're not doing the floor. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. Everything is accounted for. So then you would just go through and do those calculations. All right, I'm going to switch to B now. Now, 1 litre of paint covers 10 metres squared. So whatever your total surface area is, you just divide it by 10. Okay? Good job. Sorry to cut that one short, but I want to keep this video relatively short, well, not too long. An open top rectangular box 20 centimetres wide, 25 centimetres long, and 10 centimetres high is made from wood, 1 centimetre thick. Find the surface area. Okay, so what we've got here, 2 different types of surface area. We want to find the outside of the box. And it's saying do not include the top edge. So we're not including this part here. If you can kind of see. All right, so let's do, so we're doing the total surface area of the outside. How many shapes do we have? We've got 1, 2, 3, 4, and we're going to include the bottom, so 5. 1, 2, 3, 4, 5. And we have different size rectangles. So the front and the back rectangle is going to be 25 by 10. So we've got 2 of them. These side ones are 20 by 10. We've got 2 of them. And then we've got our base, and I'm going to just put it over here because I can. And that's 20 times 25. And we've only got 1 of them. Okay, so we've only got 1 base. So you'd find the area of those 3, add them together. All right, so inside the box is a little bit different. Okay, we're still going to have the same number of sides. The only difference is that your wood, because it is 1 centimetre thick, it's going to be different. Okay, so when you think about how you're going to lay your pieces of wood, okay, that's going to make a difference as to what the total surface area is. So we've got the base. Okay, so let's keep the base. And let's say we stuck the wood on top of it. So if we were looking at it from above, you'd have your 4 pieces stuck on like that. So that's going to change it from being a 25 by 20 base to now being so we're going to just cut off 1 centimetre at each end, a 23 by 18 base. Okay, so the inside. Now, with your other pieces, I have stuck them on top Okay, so it's we're not losing the centimeters from the it's hard to explain. If you're sitting it on top of the base, then you're not losing that centimeter, but obviously you're going to have some crossover on the ends, as you can see here. All right, can you see that? So what we're going to have now, if you can just think of your net, so your pieces of cardboard sitting out like this, okay, so that they sit on top, and they're all of a height of 10. Okay, so we've got 10, 10, 10, 10, etc., etc. But those bits on the inside now reduce as well. Now, because the wood is 1 centimeter thick, see how there's a crossover? So you could say that these sides here are what join. So it's hard to explain without actually having a physical book here, but this side here would be glued to this side here. So the length, or you could alternate that. It doesn't matter which side you use. So this now reduces from 20 to 18. And this side is also reduced to 18. But the other one still remains 25. So for our 5 rectangles, we've got our base, which is 23 and 18. We have now 2 sides, okay, that have reduced to 18 and 10. And the other side stays 25 and 10. So we've got 2 of them. So then you can just add them all together. All right, were there any other questions? So this one here, it all depends how your sides are sitting on top of each other. I just looked at the solutions and they actually had the box configured differently, but you should still get the same answer, but a tricky question. All right, bye girls.